A bat flying at 5 meters per second emits a chirp at 40 kilohertz. If this sound pulse is reflected by a wall, what is the frequency of the echo received by the bat? So, first thing I did was I listed the given values. The velocity of the bat is equal to 5 meters per second. And the frequency is equal to 40 kilohertz. The frequency at the source. That's very important because these variables will change a couple of times. Just change once, I think, in the problem. So here's a derpy looking bat. He's sounding off some sound waves to look for that wall right there. So that wall is going to intercept those sound waves and reflect them later on in the problem. So the next thing I did was I used what we learned in class. The frequency of the observer, and those eyes right there, they stand for initial. So the initial frequency of the observer is equal to the initial frequency of the source times the quantity of the velocity of sound, that's what V is, plus the velocity of the observer. I just differentiated that from that just to make it seem, they're both velocities, but different. So these two are the same, these two are, yeah. So the velocity of sound plus the velocity of the observer divided by the velocity of sound minus the velocity of the source. So we're given that we're going to say at first that the bat is the source. And he is emitting 40 kilohertz, he or she. So the velocity of the sound, velocity of sound in the book is 345 meters per second. I'm just sticking with that. And the velocity of the observer is the wall. The wall is the observer. That's what we're assuming for now. It's 0 meters per second. It's a wall. It's standing there. 345 meters per second, again, because they're the same. Minus 5 meters per second because the velocity of the source is the velocity of the bat, because the bat is the source, 5 meters per second. In the end, we get around 40.59 kilohertz. But now we have to take into account, because the problem was asking for what the frequency was what the frequency of the echo was received by the bat, we have to take into account the reflection. So the frequency, these little f's here stand for final. The final frequency of the observer, now the observer is the bat. The bat is not emitting this any longer. He has emitted his frequency, his echo thingy, and now the wall has reflected it. So the wall is now emitting a source of sound to the bat. It's a reflection. So the final frequency of the observer is equal to the final frequency of the source times, it's the same setup, the velocity of sound plus the velocity of the observer divided by the velocity of sound minus the velocity of the source. So now for the final frequency of the source, I'm using the initial frequency of the observer. Because if you think about it, the wall was the observer initially, but he was the final source of sound. So I plug that in, 40.59 kilohertz approximately. And then I substitute my values for the velocity of sound. And now the observer is the bat, so you put 5 meters per second on top, 0 on the bottom because the source is moving at 0 meters per second, and you get approximately 41.18 kilohertz.